Hello everyone, my name is Adrian Bablinski, and welcome back to this awesome tutorial series where we learn the ins and outs of Unity and Unity C#. So last time we left off, we created this lovely code for our coins that when we pick them up, they get destroyed and points get added to our system. Also, when we hit spacebar, we can't fly off the face of the earth by continuously pressing spacebar, but we have to be grounded. So that's pretty cool. And now we're gonna add a little rotation feature to our coins so that they don't look like church wafers, or from the symbolic pictures of a wafer. It's gold and it's flat. We're gonna make it rotate, and we're gonna do this by using a function we've already added to our player, which is our player rotation function. So right here, where we have a player rotation, we're going to do basically the same thing, except a little differently to show you two ways to skin a cat. So let's get started. On our scripts folder, I'm going to right click, create C# script, and I'm going to call this coin rotation. Enter, open up this script, reload all, and we're going to need one cool thing, and we're going to need an actually we're going to hold that off. We're going to first just make it rotate, and to do that we can do GameObject dot transform, right? Dot transform. And you might be thinking, wait, on our player script we didn't do that. We did this whole get component thing, and that is one way to do it. But since these are static variables, such as the game object inside the collider, we don't need to do get component. We can just do dot and the script or the component. So with that said, we don't need to do dot get component. We don't even need to nest the variable to make it look pretty. We can just do game object dot transform. And remember, lowercase g makes it the current game object. Capital G makes it the class game or the variable game object. So lowercase g. So after that, our transform dot rotation. We know this by now, or rotate. And here we need a vector 3 Euler angles. And last time we did 0 or information, which is our horizontal input, I believe, right here, and then 0. But someone might be trying to be cool and classy, and they might just do vector 3 dot up. And you're like, what does that mean? Well, it means it's a shorthand way of writing this. In fact, it's actually writing this. So new vector 3 0 1 or 0 1 0, and that's what it's writing. However, we don't want that. We are wanting just the vector 3, and then we want to multiply the information. And it's not exactly this, but it works similarly to new vector 3, and it actually just does this type of information in the rotate and so on. However, we're just going to eliminate all that writing just to doing vector 3 dot up. Now we can multiply this times the speed, so times 5. And well, we were talking about, well, how are you multiplying a float with a vector? Isn't that like women going to men's bathrooms? Or isn't that like, multiplying apples and oranges and getting apples? Well, not really, because how does multiplication work? Right? We're gonna go back to algebra, and we're gonna erase all this, and we're gonna see a vector 3. We're gonna have 0 1 0, and we're multiplying all of this times 5. Well, now it's kind of like foiling, except not really. It's going to multiply each value. So it's going to do this. Bam. Bam. And like that. And with that in mind, we see that this will return. In fact, 0 times 5 is 0. 1 times 5 is 5. And 5 times 0 is 0. And this will be our new value, which is exactly, and this is not a lesson sign, it's a terrible parenthesis. And that will actually return what we had here, except our horizontal goes from 0 to 1. We're just going to do a constant 5. And that's what that happens here. We're going to hit semicolon and hit enter and save, not enter and save, just save, Control S, and hit play. Now, when we see that happening, we see nothing happening because the script isn't attached. So we can drag and drop all this code. We can do this type of thing to all of them. But let's say you made too much. You don't too many. You don't want to do that for all of them. You can just select all of them and just drag and drop that. Hit play, and we'll see our coins rotating. And you're like, well, that looks like a, wind chime almost. They're just rotating and all at the same speed. So let's make it look cooler by adding a little bit of variety to it. So there's 2 ways of doing it, and I'm going to show you both ways. Because I'm not cool of a cat. I'll scratch your back. And here we can do public float speed, right? And we can then go to each one and then just change the speed. It'll be equal to 5 off the get-go. And we're just going to paste speed here. Hit save. Now, remember, since it's public, and I load the variable here, it's 5. If I change the value in the public variable, if I make this 2, it will still equal 5 unless I refresh the code. Right here, reset. So, to not have that, we're just going to, I just want 5. But remember that if you're changing it in the inspector to make it finite for that object, if you want to, assign it always at 2, then make it 2 here. And now we're also going to have an int that will be random. Public int random number. And the random number will be assigned at start. And random number will equal random number, or random number, will equal random, because we're making a random range. We're making a random a sort. Random. And doing dot range makes it clamp from the smallest number to the largest number. So range. So the range between which numbers we want to get it, the max and min, or the min and max right here. As it says, returns a random float number to our object. So let's write that here. Dot range, and it returns a float. However, if the random range can only store an int, and so it will just grab an int, and we're gonna do our lowest speed will be 1, and our highest will be speed, and we're gonna do semicolon here. And you're like, wait, it's not working. And that's a fact because now we're going to men's bathrooms and, if we're women. And that's because an int cannot accept decimals. So if this is 0.5, it just won't work. It'll look really crappy. And so a good way to change this is by actually just truncating any decimal. And to do that, all you have to do is open parenthesis right in front of it, int, close parenthesis. And bam, we just did a typecast. How cool is that? We've just converted a man into a woman, basically. Or an apple into an orange. So that cool thing right here does not round. It will, if its speed is 3.9, it's 3. Just remember that. And now we can grab this random range or random number and multiply this. And now we're going to have a problem here, right? We're like, dude, this is a float. Vector 3s only accept floats. And this might not affect it since we're just doing multiplication. But if you're doing a method like this, yeah, you're gonna get you're gonna get monodevelop screaming at you right here. So to convert ints to floats is not as easy, and there's 100 ways of doing it. But if you want to be really cool, you can just do this. I'm gonna blow your mind. Times 1.0f. And now it multiplies it, leaves that 0, and then the computer will be happy. But again, for this purpose, we don't need to do that. But if you ever have a problem, int to float, error, then just do this. And I'm gonna hit save, and then we're gonna go into our Unity game, hit play, and in fact, they are spinning at the same rate. And the reason that's happening is because our random range is at 2. And so we want to change that to, let's say, 7 or 5. And when I hit save, I'll save my scene and save my project. And you'll see that the coins now spin at different intervals. And if you want to make it even more crazy, we can even go as far as 9. And now when you hit save, of course, you'll have more variety. And I like 10. Some of them will go to 10, and that will be pretty crazy. So, that's just, you can play around with it, but it's a pretty cool feature. And it's used pretty often for random events that happen in games. So, pretty cool feature. I like how they turned out. Next, we're setting up our enemy.